Hello, and welcome to My Two Cent. My name is Paul Emerson, and I will be giving you my 2 cent. Today's topic is field theory, the nature of dimensional retention. For about over a month now, I've been delving into the science of faster than light speed technology and anti-gravity. The topic is much more difficult than I had originally intended it to be, for the nature of communicating ideas is always subject to ambiguity and semantics. The biggest issue when communicating with someone else is you have to deal with the universal understanding that if a person doesn't understand what you're saying or is not willing to accept what you say, they're going to accuse you of either being ambiguous or simply being semantical. While the science community can tell us anything, they can say that the universe is expanding into nothing, that the universe is expanding into that the universe is everything, and that everything is expanding into nothingness, or that the universal expansion does not have to be defined as expanding into something when the universe is everything, that infinite space expands infinitely into itself. The contradictions that are allowed by the mainstream scientific community, while understandable, limits a layperson like myself's ability to communicate any form of reasoning without being told that I need to go back to school and study more and learn more. And it's unfortunate because it kind of defeats the purpose of an intellectual exchange, which is the goal of my 2 cent. And my Due to my lack of ability to convey things visually, I can't express what's in my head in any way that I will not be told that I'm being semantic using circular logic, or I'm just simply ambiguous. So what I'm going to do is I'm going to simply outline those things of my understanding that I have translated into a working a working proof for what I'm going to say is space, and I'm going to speak on space separate from time for this, because the end game goal is to describe a practical approach to the theory of faster than light speed technology. And one of the principles of faster than light speed technology is the ability to warp space. The ability to warp space requires space to be something tangible. There was an experiment, and I can't remember the specifics, where we, the scientific community, determined by studying light in a very specific way that there was no physical manifestation of the medium that we refer to as space. In doing that, they opened the door to a lot of advancements in physics and quantum physics, but they shut the door in a lot of classical mechanical operations and thought experiments when describing space. For example, the scientific community refers to space as a fabric continuously. This is unfortunately not even possible because a fabric requires a medium. You can't describe fabric without alluding to a medium. So the analogy of a fabric for space ultimately contradicts the notion that space in of itself is not a medium. So with that being said, with that understanding being put out there, and with nowhere else to run to, I'm just gonna have to sit here and open myself up to attacks from trolls. So I'll start with the four causes, because I feel like that trying to define space what causes will probably be the most non-ambiguous direction to go into. So the four causes that I've come up with are: space is quantized physical boundless dimensional extent that forms the inherently knowable foundation of material existence. As a material cause, space is comprised of emptiness and serves as a medium within which things have a place where they are allowed to exist. As a formal clause, space is defined as dimensional allegory to a set of coordinates used to best define its finiteness. As an efficient clause, space is where observation occurs, indirectly knowable but giving rise to all aspects of reality and existence. Space is the unobserved object upon which and within which all observable objects are said to be. As the final cause, space is to give rise to existence. Space is where everything inherits their existence from and where everything are said to exist once they come into being. Okay, one other proof that I need to give is the nature of waves. There are two types of waves. One type is called transverse waves, the other is called longitudinal waves. Transverse waves have a vibration that is perpendicular to the direction of travel. Longitudinal waves have a vibration that is parallel to the direction of travel. In classical mechanics, waves only transfer energy through space, not matter. The features of a wave. The wavelength measures the x-axis. Wavelength is the full cycle of a wave from one point to another point. The easiest way to define a wave is the distance from crest to crest or from trot to trot, and its length is measured in meters. Amplitude measures on the y-axis is the size of a wave, measured from the center of the wave, the equilibrium to the crest, or from the center of the wave to the trot. The amplitude is never measured from the crest of the wave to the trot of a wave. Frequency is the number of complete waves to pass a point every second. Frequency is the number of complete waves to pass through a local or duration through a location for a duration of time, and is given in the units of hertz. An example is the number of cycles is if an example of this is if the number of cycles is 10 and the time is 2 seconds, then 10 divided by 2 equals 5 hertz. Using these things, we can calculate the speed of a wave. Speed equals frequency times wavelength. Reflection is a change in the direction of a wave front at its interface between different mediums, so that the wave front returns onto the medium which it originates. Refraction is a change in the direction of a wave passing from one medium onto or from a gradual change in that medium. Now, I use the term retention. Retention is the physical medium of spatial dimensions. Expansion is an outward translation of a medium. Contraction is the inward translation of a medium. The infinity is called retention. The conflict that we have when it comes to our understanding that the universe is expanding in all directions is based on our interpretation of our observation of the universe. When we look up into the sky and we observe cosmic background radiation, we see that all points in the universe are moving away from all other points in the universe in a very uniform and very even manner, with disregard to the very uneven nature of the location of galaxies in the universe. Scientists tell us that the universe is even, and this is relatively true. It's relatively true. The fact of the matter is that the universe is very uneven. Evenness is a Cartesian plane. When all points reside at exactly even distances away from each other, that is even. If just one point is not specifically located at the exact same distance away from each other, then you cannot define something as even, such as the nature of understanding the terminologies that you use. The universe is very wrinkly, very disordered, very chaotic, very random. It is the fact that the universe is perfectly random, it is the fact that the universe is perfectly disordered, that scientists say that the universe is even. Because absolute chaos in of itself is a form of order. I bring this up because this is where our conflict begins. When we look up in the universe and we see that everything is moving away from everything else, we cannot ignore that observation. because it means that there is some force that is causing all things to expand away from everything else. I call this anti-gravity. Gravity, as I've stated before, the force of gravity is a omnidirectional universal pull of force of attraction that we observe on our scale. When we put two magnets on a table and we put them against each other, we can see them attract. And if we rotate one of the magnets 90 degrees, which is usually necessary for any observation, for any physical, experimental, observable observation, if you rotate one of the magnets 90 degrees, you will see them repel. So any two magnets brought together usually attract and or repel, and rotating that magnet 90 degrees will ultimately cause the two interactions to now be the opposite, which would be repulsion or attraction. Everything in the universe is attracted to everything else, such as described by Newton's law of um, classic. I'm sorry, Newton's law of general gravitation. On a local scale, we see everything being attracted to everything else. On a much larger scale, we see everything moving away from everything else. The way that I perceive it is that gravity is a force of attraction on the and within our three-dimensional universe. Motion that we observe as universal expansion is the force of gravity in the higher retention or in the fourth dimension. I prefer to use retention to describe dimensionality because it's less ambiguous. So in our third retention, we see gravity as a universal attraction. In a fourth retention, we see our universe expanding into the fourth retention as fourth dimensional gravitational repulsion. The force of gravity acting as a universal force of repulsion is what we see in Hubble's background radiation of universal expansion. If you were to if you could take gravitation and flip it 180 degrees through the fourth retention on the three-dimensional axis, then you would see that the whatever force drives universal expansion would start to contract, but whatever force causes localized gravitational attraction will begin to expand. That means that the force of gravity that binds everything together would start to rip everything apart, and the supercluster force that causes supergalactic clusters to move away from each other will start to come together and coalesce. And like I said before, it's a very difficult thing to describe. What this implies to me is that when we speak of the Big Bang, the the universe was defined to be a super a I'm sorry. When we speak of the Big Bang, we say that the universe was a the okay. When we speak in the terms of Big Bang, the present day universe, the observable universe, is 13.6 billion light years in diameter, or the radius. We'll say it's 13.6 billion years light years in radius, expanding into what scientists would say itself. The known universe, the known universe is expanding into existence. Existence is a very even, very static, four, five, fifth dimensional, well, 11. I won't say specifics because I don't know. Existence is a undefined number of higher retentions, which allows our finite three-dimensional universe to expand into it. Electromagnetism is a force which operates within the three dimensions. Gravity is a force which operates through the third retention into the fourth retention. So gravity is pulling all things into a higher fourth retentional state, which is beyond our observable interaction. But it is doing this in a way that we observe 50% of that force, which is the attraction, the universal attraction of gravity in our third dimensional universe. This is the reason why we say that our three dimensional universe, our three retentional universe, would have had at one moment in time completely coalesced into a singular moment that we define as the early universe, or the singularity of the universe known as the start of the Big Bang. We say that the mass of the universe moved into a volume that was infinitely small. But one of the things that I have said earlier on one of the things that I had mentioned earlier in one of my videos on my 2 cent is that when you describe a line, you describe a two-dimensional shape in our three-dimensional universe. When you describe a curve, you describe a three-dimensional line in a fourth-dimensional universe. That is to say that in a fourth-dimensional universe, if you wanted to draw a line, you would have to draw a curve. In all mathematics that apply to a curve would be the basic math that you would use to describe and illustrate a line in a three-dimensional universe, in much the same way that we have to use a sphere, or an allegoric sphere, or an allegoric cube. Basically, in a three-dimensional universe, a curve is a line, a two-dimensional shape, whereas in a three-dimensional universe, a line is a two-dimensional shape. So their two-dimensional shape is our two-dimensional line is a two-dimensional curve in a higher dimension. Our three-dimensional cube is our three-dimensional cube is a three-dimensional object in a fourth. Okay, this is why it's important to be able to use visuals, and I can't, because I've determined that it's not it's something that's beyond my skill set. Okay, in our three-dimensional universe, we describe points, lines, planes, and points, lines, polygons, and polygonal solids. Right? Points. So in our three-dimensional universe, we define points, lines, polygons, and polygonal solids. The highest object we can describe in a third retention is a polygonal solid. A point is 0 dimensions. A point is 1 dimension, 1 retention. A line is 2 retention. A polygon, right. A point is 0 retention. A line is 1 retention. A polygon is 2 retention. And a polygonal solid is third retention. The tetrahedra is a fourth retentional object. For the sake of this specific theory of the nature of dimensional retention, I'm going to use the term hyper. Just for this, I'm going to use the term hyper to describe the fifth retention. It needs to be clear, or I want to be clear, that I say retention because the fourth retention is allegoric to the fourth dimension. I want to say retention because I don't want the geometric nature, the geometry, the spatial nature of the fourth retention to be confused with the allegoric one dimension of temporal, or time. Time and temporal are the same thing for me. Time is what we measure. Time is the unit of measurement for the physical existence of temporal. Temporal being a form of temporal being where the mechanism for time treated at physics uses two things to describe itself: particles and fields. Time measures the particle and field nature of the temporal dimension. That is to say that time is a Cartesian plane that describes the motion of events occurring in space. Events in space occur through time. So a moment and a location in space experiences moments in time. Time being the measurement of temporal. So a moment in space is a retention, and its moment in time is a temporal. So you can look at it as the best way to view it is that time is a treadmill, and the geometry on top of that treadmill inherits the ability to translate through time as a medium. When you treat time as a medium, when you treat time as a dimension, time inherits the ability to translate through that medium, and that inherence is the temporal. So now that I've completely got off track, I will go back to points being zero retention, line being one retention, polygons being two retention, polygonal solids being three retention, tetrahedra being fourth retention, and hyper I don't want to say hyper solids. I'll say hypersolids being the fifth retention. The tetrahedra is the commonly used term to describe a fourth dimensional cube. The tetrahedra, the tetrahedra, we know what it is. We know that it represents fourth dimensional spatial retention. The hyper solid represents fifth dimensional spatial retention. Now we need to go back to earlier when I said there are two types of waves. One type is called transverse waves, the other is called longitudinal waves. Transverse waves have a vibration that is perpendicular to the direction of travel. Longitudinal waves have a vibration that is parallel to the direction of travel. The direction of travel is always represented as a one retentional line. One retentional line. When describing amplitude and frequency, that one retentional line is an equilibrium. The equilibrium is how you are able to determine a crest and a trot. Lines are comprised of points. And this is where it's going to start getting iffy. It's going to start getting iffy because the only way that I could think of, I can spend the next 15 to 20 minutes teaching you about geometry. And the only thing you're going to do is walk away with an understanding of geometry. My goal is to explain field theory and the nature of dimensional retention. My goal is to explain exactly what is the aspect of space-time that we define as space. And to do that, I have an understanding. I have an accepted reasoning in my mind that allows me to rationalize what space is. And I don't understand, I'm not 100% confident in my ability to translate this understanding to you, the viewer. But I'm going to try. If you define a Cartesian plane and you give it an x-axis and a y-axis, and if you want, you can give it a z-axis. At the very center of that Cartesian plane, you give it a coordinate of 0. We have already established that 0 dimensions are defined by points, and those points have no length, no width, no volume, but they do carry location. So the location 0 is the very center of an undefined Cartesian plane. Location 0 has no length, it has no width, and it has no length, it has no width, and it has no depth. If the Cartesian plane that we have just illustrated is a retentional plane, then it is comprised of space or dimension. But it is not defined. But it is not but it is not comprised of temporal. The retentional plane that we have just illustrated is comprised of geometry, but not time. If we draw a second Cartesian plane and we give it an x, we give it a y, and if we want, we give it a z. Then the second Cartesian plane has a location that is zero, temporal. The zero temporal of this retention plane is describing time, the passage of events and moments. Like its spatial counterpart, it has no past, it has no present, and it has no future, but it does carry what will be the term. The term for time would have to be allegoric to location. It has a moment. I guess moment or presence, not presence. It would have to be moment, because a moment there can be a moment in space and there can be a moment in time. So allegoric to space, we treat temporal the same way. Now here's the leap. This is the leap of faith. This is the moment of ambiguity and the moment of semantics. This is the true moment where the statement that I'm going to make goes from being a absolute universally established quantifiable proof to a metaphor or philosophical statement which one has to accept as true. If we take these Cartesian planes and we define them as fields, and we say that every coordinate on these fields, and we say that every coordinate on these fields is a how do I want to say it? We say that every coordinate on these fields. Oh, that's how it works. We say that every coordinate on these fields is is allegoric to a Planck's length or Planck length. Then we can very elegantly, using the physics, using the formulas and equations of quantum mechanics, describe the field of space-time, the field of space and time. A Planck length has three components, and I'm gonna look them up on Wikipedia because I do not have them memorized, and I want to explain what they are properly. There are Wikipedia says in particle physics and physical cosmology, Planck units are a set of units of measurement defined exclusively in terms of five universal physical constants, in such a manner that these five physical constants take on a numerical value of 1 when expressed in terms of those units. So what this means is that if you define a point which is 0 dimensions, but it carries a value of location. A point has no length, it has no depth, and it has no length, depth, or width. but it does carry location. What we can do is we can use a Cartesian plane to define Planck's lengths, Planck's units. And what occurs is that at location 0 of a Cartesian plane, there are 5 universal constants which describe that there are 5 universal constants which define this location that has been established on this Cartesian plane. Those constants are the speed of light in a vacuum, the gravitational constant, the reducer of Planck's constant, Coulomb's law, and the Boltzmann constant. The Boltzmann constant is a physical constant related to the average kinetic energy of a particle in a gas with the temperature of the gas. The Coulomb's law is Coulomb's law is a proportional constant of electrodynamic equilibrium. Reduce Planck's constant. The Planck's constant has dimension or physical action, i.e., energy multiplied by time or momentum multiplied by distance or angular momentum. In SI units, the Planck's constant is expressed in joule seconds. Implementing implicit in the dimension of Planck's constant is the fact that the SI unit or frequency, the hertz, represent one complete cycle, 360 degrees or 2 pi r radius per second. And angular frequency in radius per second is often more natural in mathematics and physics, and more formulas use a reduced Planck's constant. The gravitational constant, which is the gravitational constant, Newton's gravitational constant, is an empirical physical constant involving in the calculation of gravitational effects. Where is it? I'm surprised it's not just here. The gravitational constant. I know what it is. Well, it's constant. I'm not gonna. Yeah, Newton's gravitational constant. It's not. It's not listed in Wikipedia, and I don't want to quote off the top of my head. But in the Newton, and then the speed of light. I don't want to get distracted. The speed of light. The speed of light in a vacuum commonly denotes the speed of light is the maximum velocity of light that can travel through a vacuum. So those 5 constants give us the values of our give us the value of our point. With those values, we can go back to I lost. Here it is. Using Planck's constants, using those values, we can say that before the Big Bang, and here's the leap of faith. When we look at the observable universe, we see everything expanding outward. If we go back to the Big Bang, we say that the Big Bang was a singularity. The singularity of the Big Bang was exactly 1, 2, 3, 4, 5. The singularity of the Big Bang can be defined as being infinite and infinitely small. The singularity itself was infinitely small. The observable singularity was exactly 1 Planck's length and radius. One Planck's length in radius, where radius defines retention. That is to say that the singularity of the early universe that was observable, if the known universe has an observable horizon which we can observe, and a knowable boundary beyond that observable horizon, then it is safe to say that an infinitely small universe, like a point which has no length, no width, and no depth, had an observable behavior which, based on our current laws of physics, would have been equal to a Planck length in radius. And it has to be in radius because 2 points define a line. You cannot have a no dimensional geometry. The smallest unit of geometry that can be described in our universe, in any universe that would be observable, would be a line, because you need 2 points to define one line. Since we are using Planck lengths, since we are using Planck's constants to define these units of geometry, while we have to obey the principles of geometry as an ideological mathematical model for the universe, we can accept their physical nature as being true for this thought experiment. So 2 points define a Planck's length, where the length itself is equal to the Planck's constant, but the points themselves are not defined, because that's just how it works in geometry. I cannot describe a line with points and give those points dimension, because then I have to measure the dimension of the points as well as the dimension between the points. And if I do that, then I lose the geometry itself becomes ambiguous. If you have a circle with a line with another circle, the point in the center of the circle is the circle. So you get infinite regression. So to avoid infinite regression, geometry was wise enough to say that the boundaries between any given length have to be defined by points which are undefined themselves. The length itself is an infinite number of points whose boundaries are undefined. Geometry was wise enough to give us a perfect definition for defining a length, and that is radius. Radius is always the distance from a center to an edge. By giving us that definition, we don't need a boundary to define the radius of a point. With the analogy of with the analogy of a line being 2 retention, a polygon, with the analogy that a polygonal line being 2 retention, a polygonal solid being 3 retention, and a tetrahedra being 4 retention, and a hypersolid being 5 retention, we can say that the observable singularity of the early universe radiated out in 2, 3, 4, 5, 6 infinite dimensions within our universe, with a diameter exactly equal to 2. What would it be? With a diameter is equal to 2 Planck's constants. 2 Planck lengths. That's what I'm looking for. 2 Planck lengths. If we go back to our Cartesian plane, we draw a 0. The 0 is no location, right? It's 0 location. I'm sorry. We draw a plane. At the very center of the plane, we put coordinate 0, which, when you draw a Cartesian plane, coordinate 0 has no length, width, or depth, but it does define location. However, now this Cartesian plane is a representation of Planck's constants. So at 0 location, from region 0 to region 0 to region 1, we define 1 Planck length. So the early universe would have extended into positive x1, negative x1, positive y1, positive x, positive y1, negative y1, positive z1, negative z1, where x is one dimension, where y is the two-dimensional plane, and z is the three-dimensional cube, the polygon. However, we can allegorically state that the observable singularity also extended into the unobservable fourth retention, which would which we can say is w, or we can assign it any value. But for the sake of argument, we'll say that wx, it would be yz, vwxyz is the Cartesian plane that we're going to work with. So the observable singularity extended extended into coordinates v, w, x, y, z, and was a hypersphere of 5 retention, infinitely large, infinitely small and unknowable, but observably exactly equal to one, exactly equal to 2 Planck's lengths in length. 2 Planck's lengths, yeah, two Planck lengths in diameter and 1 Planck's length in radius. It has to be 1 Planck's length in radius because the science of a Planck's length states that it is the smallest unit of space and time that is recognizable in our universe, because below that value everything becomes uncertain and unknowable and unmeasurable. So to establish some coherent nature of understanding, we're going to go with that. Now, the observable universe, I'm sorry, the observable singularity is establishing the observable singularity is establishing a particle, cosmic particle, inside of a infinite expanse of nothingness that is a field. Here's another leap of faith. If the singularity is infinitely small, if it was small, then it had volume. And if it had volume, then it had to occupy space. So what did it occupy space into? For me, it occupied space in infinity. And it occupied space and the nothingness that is infinity. Our observable universe as a infinite unobservable infinity that gave rise to an observable finite singularity existed inside of existence. Our universe is the boundary within that singularity, and the boundary outside of the singularity is existence. Allegorically, this extends all the way up into 11 dimensions through universe, existence, multiverse, omniverse, omni-existence. And I'll talk about those later. Those are just simple, those are allegoric thought experiments for higher dimensions, and I'm trying to establish the physical manifestation of what is space and time. So moving on from that, this the teeny the infinitely small singularity is expanding into, I'm sorry, the infinitely small singularity is exactly 2 Planck's lengths in diameter, 1 Planck's length in radius, existing on a, for now, we'll use a two-dimensional Planck's constant Cartesian plane at locations at location 0 with an infinite retention around it. The reason why I wanted to put the reason why I'm using a Cartesian plane to describe the early universe on is because the retention plane is one part dimensional retention field and 1 part temporal retention field. Because one of the things about our universe, as we understand it and choose to describe it, is that our universe exists in only one dimension of time and one dimension of temporal. So I can use the analogy of a Cartesian plane to illustrate that. By definition, the universe should be described on a line. It should be in time should be an array pointing in one direction. That's how it should be allegorically described. But I want to use, I want to use the excuse me, but I want to use a field because I want to use the Cartesian plane because the Cartesian plane is the best analogy for describing a field because it's been overused by scientists. It's been overused by modern day physicists to describe space time and gravity and all that other jazz. So the field is a perfect analogy for the singularity to exist within as a representation of time. Something occurred and the universe expanded. As it expanded, it went from having a diameter of 2 Planck's constants, 2 Planck lengths, to 4 Planck lengths, to 8 Planck lengths, 16 Planck lengths, etc., etc., etc. It expanded exponentially. Well, technically, scientists invented the Planck's constant to measure the universe, and its expansion rate was not exponential, it was greater than exponential. I don't know those numbers, and I won't try to use them because if I try to use those numbers incorrectly, then my entire statement breaks down. But we do know that they have been measured accurately. For the analogy, we're just going to state that it expanded. What it expanded into was a field of time. Or earlier, I stated that. Um, Earlier, I stated that. Give me 1 second. Earlier, I stated that a wave. Earlier, I stated that a wave has a length. No, that's what I'm looking for. That waves are measured in amplitude, and amplitudes have a crest and a trough. Here is another leap of faith. But this leap of faith is the one that will establish exactly what space-time is. With everything that I have just said, this is the leap of faith that will absolutely establish what space-time is. I mentioned that a point has no dimension. The definition of a sphere is to draw a point and describe a line to a specific distance and to create a perimeter around that point. That's the definition of a circle. If you take that same analogy and describe it in any dimension, 2 dimensions, 3 dimensions, 4 dimensions, 5 dimensions, you just get larger and larger and larger spheres. Volume is the measure of the area of any given region of space. The area of any given region of space is volume. We live in a universe where we exist in a state where the idea of no volume is foreign to us. We cannot accept the empirical notion of no volume. So we cannot describe a point without acknowledging that it must have some volume. It must have some volume. It absolutely cannot exist as zero volume. So the analogy of volume gives rise to the notion of dimension, which I refer to as retention. So we cannot describe a point without establishing retention. Imagine, if you will, a point which has no volume. Imagine, if you will, a second point that has no volume. And imagine, if you will, an infinite number of points between those points, which describes a line which has no volume. Consider that this region of no volume is the equilibrium line that defines the amplitude, the equilibrium line which describes the amplitude of a wave at no volume. This allegorically is nothingness. Absolute nothingness. Absolute, unequivocal, beyond recognition nothingness. Now imagine, if you will, another line with the same exact conditions that has a value of 1 Planck's length. If a rectangular polygon is defined as having some length and some height, how then do you define a two-dimensional polygon against a one-dimensional line with a width of 1 Planck length? When does a line, as the analogy for one-dimensional, when does the line as a one-dimensional allegoric representation of space differentiate itself from a plane, which is a two-dimensional representation of space? Because the line must have no dimensions to define it. But if the line itself is a higher dimensional entity, then it's indistinguishable from our polygons in our third dimension. The reason why I say this is because a two-dimensional line in a higher dimension allegorically would be a their smallest the their smallest representation of dimensionality, and by them or they, I'm implying higher dimensional beings doing the math to describe their universe in the same way that we, as defining ourselves as lower dimensional beings, try to describe our three-dimensional universe. Their line to them will look straight, but to us, their line will be curved. A curved line cannot be defined without using length, without using coordinates x and coordinates y. What makes a line is you can illustrate it with one coordinate. You can say that at location 1 and at location 2 on x1 and x2 is a line. Point 1 and point 2 they define a line. You cannot, if you describe it a Cartesian plane, you cannot draw a curve on that line. You cannot draw a curve on that plane and define that plane as a line. And define that curve as a line on that plane, because you need two coordinates to do so. Two coordinates to a fourth dimensional entity would actually represent one dimension for them. In the same way that we use two coordinates, we use a Cartesian plane, and we define location 0 as 0x and 0y to use two coordinates to describe a one-dimensional line. So each point is defined with two values to define it, even though it's a one-dimensional object. The relevance of this is to bring up another leap of faith. Imagine, if you will, that the universe is comprised of fields which are defined by waves. If you draw a wave and you draw equilibrium, the equilibrium is a point of zero, what is it? Zero crest and zero trough. When a wave has zero crest and zero trough, it defines a line. The frequency, if we say that there's a frequency of 1 to 10, where the smallest trough has a height of 1 and a crest, we say that the smallest crest and the smallest trough has a, in this frequency of f, has a height of 1 and a trough of 1, or a height of 10 and a trough of 10 from a common equilibrium. What occurs if this wave, for whatever reason, has a frequency of 11? What occurs is, if you draw a plane and you put a trough through that plane, you draw a plane, you put an equilibrium point through that plane at location 0, and you draw a wave with a trough of negative 11 crossing through the center equilibrium to positive 11, it comes back down, does it again. What you're going to get is, you're going to get points of intersection with this higher retention. This higher point at location 10 is going to now describe an equilibrium. This equilibrium is going to give you a crest with no trough. This crest has a peak of 1, because 10 minus 1 is 11. 11 minus 1 is 10. So allegorically, this is what you're getting. What I'm ultimately trying to describe, and I'm doing it poorly, is an 11th dimension. Everything below the equilibrium point of 10, everything below the equilibrium point of 10 is unknowable. The observer who is standing at the equilibrium point of 10 sees troughs that are exactly 1 unit or 1 hertz, we'll say 1 hertz in strength, coming out of nowhere and disappearing. The observer at location at hertz 0 is observing a trough of 11 that is passing up into and out of the boundaries of his observable universe, of his observable extent. He cannot see the peaks and the troughs. He can only see the lines that pass through. These lines are, where is it? These lines are vibrations that appear to be perpendicular to the direction of travel. So these lines, although they are longitudinal waves, appear to be transverse waves. So longitudinal waves, so when a longitudinal wave has an extent which exceeds the boundaries of the dimension in which they occur, they will appear as longitudinal waves. So we can allegorically say that longitudinal waves can be the result of higher dimensional transverse waves. Sorry. So what I'm getting to is that this is the way space ultimately works. At the very lowest, there is a value in my head that I don't know how to convey. Number if you draw a point and you put zeros on those points, we know that to the left of that value is infinitely is is infinitely large, and to the right of that value is infinitely small. If you draw an infinite number of zeros going to the left, and if you draw an infinite number of zeros going to the right, you still have zero. You still have no thing. In much the same way, the analogy would go that a line in our universe, or in any universe, and I'll say it this way: in much the same way that a line drawn through the retention has no trough and it has no crest and it has no trough, therefore it cannot describe a wave. Starting on the right side of the starting on the right side of the decimal point, if you draw a one, if you draw a zero, and after that zero put a one. Now, between the point and the one, describe infinite zeros. I don't know what to call this analogy. I don't know if this analogy exists anywhere else, but this is absolute observable smallness. This is absolutely the highest any this unit defines the separation from nothing and somethingness. This is the absolute this is absolutely how small you can go and be something before you're nothing. Because to change that one to a zero is to cease to exist. This is the very smallest unit quantity of everything. It's the absolute smallest quantity of existence. This value, if applied to a wave crossing the equilibrium, where the equilibrium is equal to zero point 0, the value of the equilibrium point is equal to zero point 0, and the value of the trough is equal to 1 is equal to 0.01, whereas the zeros, infinite zeros between a decimal point and a 1, infinite zeros between the left side of a decimal point and a 1. If you use that to describe a trough, I'm sorry, to describe a crest and a trough, to generate a wave whose what is the how do you define the amplitude, the frequency? The frequency is the number of complete waves to pass a point every second. If the frequency is also equal to zero point 0, I'm sorry, is equal to an infinite number of zeros between a decimal point and a 1. Taking into consideration the nature of Planck's constant, what we have is the absolute smallest knowable quantity which can be defined as existence. And it is upon this that all of space, all of time, all of change, all of matter, all of energy is built upon. This one singular unit, of quantized value is ultimately what we will be. This is what we as humans are ultimately looking for as we as we explore and experiment and measure the quantity of the observable universe. The universe is a point that is exactly equal to this quantity. I'm sorry. Okay, let me rephrase that because that didn't come out correctly. If you draw a Cartesian plane for the infinite universe, not an allegoric part of the universe or a bubble universe inside of a bubble universe inside of a bubble universe. If you draw a Cartesian plane to define the infinity that is the universe, the infinity that is existence, the infinity that is all omni-existence, the infinity to which I define as um, infinite indefinites. And in that Cartesian plane, you define a absolute center at location 0, and you give that location this value. What you have just defined is the foundation of the knowable, literally the foundation of the knowable. There's not even any reason to put existence or universe behind it. This is the foundation of the knowable, because much like Planck's constant, at location 0 and location 1, the distance between those two is the equilibrium point, which does not exist. So all of existence is separated by a space of non-existence, by absolute non-existence. Basically, what you're doing is you're saying 0 from 0 to 1 is separated by zero point 0.0 distance. And you can do that because the distance between 0 and 1 is infinite. The distance between 0 and 1 is infinite, where the distance between 0 and 1 is infinity, where infinity is equal to a decimal point with infinite number of zeros separating a 1. And that 1 gives rise to absoluteness of something. This is how, this is the foundation of space-time. And I don't know any other way of putting it. I really want to describe it in a very elegant way, but I just don't know how. So I'm gonna leave you guys with that. And as always, my name is Paul Emerson, and I have just given you my 2 cents. I didn't even check to make sure this was recording. It looks like it's recording. Marco!